Welcome back to part 2 of the coordinate plane and graphing linear equations. Today we're covering standard form in this episode. Let's go ahead and jump right into it. Okay, standard form. What is standard form? Well, that's when we have the x and y on one side of the equal sign together. And generally you'll see it in this form. You'll see ax plus by equals c, like that. Now, what are some keys to standard form? Key number 1. X and Y are on same side, okay? And I just talked about that, and you can see that here in this example, you see X and Y, and they're both on the left side of the equal sign, okay? The other key is there's no fraction coefficients of X and Y. So A and B are not fractions, don't have any fractions in front of A or B, and that's what you call standard form. Now, standard form is pretty useful, and a way that it's useful is, we're going to talk about in a second, but it uses the intercepts to graph. So the first step with graphing the standard form is find X and Y intercepts. Okay. Now, how do you find the X and Y intercepts? Well, we kind of did this in the previous examples in the other video, but essentially what we found out, if I scroll up here, is that the X-intercept always has a Y value of 0, and the Y-intercept always has an X value of 0. So if we come back here, and we want to find the X-intercept, then we need to let Y equal 0. In our equation, okay? So remember how when we had the table of ordered pairs, we could pick any values we want? Well, we know there's an infinite number of possible values that will satisfy this equation. So we want to find very specific ones. We want to know where X is when Y equals 0, and that will tell us where it crosses the X-axis. Now, when we want to find the Y-intercept, it's exactly the opposite. We want to let X equals 0, and then we will find our Y-intercept. So once we do that, we're going to plot, once we find our X and Y-intercept, we plot the intercepts, and then we simply connect our line. Connect dots with line. That's it. Now, it's the X and Y intercepts part that probably trips people up the most, okay? And this is assuming that's in standard form. So assume in standard form. Standard form. Okay, you have to get it into standard form first. You'll see here, this equation is already in standard form. X and Y are on the one side of the equal sign, and they have no fractions. So find X and Y intercepts with a graph of 4x minus Y equals 3, then graph. Okay, so we're going to go ahead and start. And to find our X-intercept, what did we say? We said let Y equal 0. So I'm going to go ahead and do this in red to show that we're finding the X-intercept. I like to put it in a box like this. And then I go 4 times X. Now, if we're finding the X-intercept, we need to have X written here. This is a very important step people kind of take for granted. But you need to have X written in the equation to know that you're solving for the X-intercept. So minus, and we're plugging 0 for Y, just like we said here, let Y equal 0. Maybe I'll do that in purple. That'll be a little bit more clear. We're plugging in 0 for Y, and that equals 3. That's the whole point, okay? We have X by itself. We have no Y because we're looking for the X-intercept. So now we have 4X equals 3. Divide by 4 to both sides. We get X equals 3 over 4, or 0.75. Okay, so we have our X-intercept. It is 0.75. Y-intercept. I like to go ahead and make another box over here. Y-intercept. Okay. I need my Y. Minus Y equals 3. And then we have 4 times, instead of writing X, I'm going to write a 0. Okay, just like we said up here, we need to let X equal 0. Now, notice how I have my Y written here. If I have my Y written, that means I'll be able to find the Y-intercept. Okay, so that's one way to remember it, because a lot of people, when they try to find the Y-intercept, they plug in 0 for Y, and that's not what you do. Okay, so let's go ahead and solve from here. So we have 0 minus Y equals 3. That's negative Y equals 3. Divide by negative 1. Divide by negative 1. We have Y equals negative 3. Okay, so we have our x-intercept, we have our y-intercept. Not sure why I circled the y-intercept, but you get the point. So I have them. Now I'm going to plot those points. Well, if at first glance you're like, what? What points? I just see 0.75. How is that an ordered pair? You can make this into an ordered pair. Keep in mind that we plugged in 0 for y to get that. So that's technically our point there. Anytime it's an x-intercept, the y value equals 0. Keep in mind that we plugged it in there, okay? We plugged in 0 for y. Now for our y-intercept, we plugged in 0 for x. So that is the location. So if we were to go ahead and plot these on the coordinate plane, let me go do my y-intercept. We have 0, -3, okay? How did I get there? I went 0, I had to go 0 left and right, and I go down 1, 2, 3 to get there. For my x-intercept, I'm gonna go to the right 0.75. I always start with my x coordinates, right to 0.75. That's right in this area. And I don't go up and down at all because it's an x-intercept and the y value equals 0. Now what do? I connect my lines. And I'm gonna go ahead, whoops, sorry about that. I'm gonna go ahead and connect it with purple. Why not? And all you need is 2 dots. Okay, the minimum number of points you need are 2. You need 2 points to make a line and to see what direction it's in. For other types of equations, the more dots, the more kind of precise you can see where it's going. But the minimum number is 2. Number 2, find the x and y intercepts of x plus 2y equals 0, then graph. Okay, so now let's go ahead and try this one. Okay, so we're going to plug in for our x-intercept. We're going to plug in y equals 0. So we're at x plus 2 times 0 equals 0. Okay, and for our y-intercept, we plug in the exact opposite. We plug in 0 for x, y-intercept. Okay, so now we have 0 plus 2y equals 0. Notice how I plugged in 0 for x when we're trying to find the y-intercept, and 0 for y when we're trying to find the x-intercept. So we get x equals 0, and then we get 2y equals 0, and then we get y equals 0. Now, this is a problem because we have x-intercept is 0, y-intercept is 0. So that's the point 0, 0, and the point 0, 0. Let's see why this is a problem. We go ahead and plot both those points. Where do they both end up? 0, 0 is here, 0, 0 is here. Notice how we don't have 2 points. That's a little bit of an issue. So what do you do in this case? Well, there's an extension, okay? So number 4, this is if necessary. You find any other point if both are at origin. Okay, so we find any other point if at the origin. What does that mean? Well, we can plug in any value for x and see what we get for y. So here, because they're both at the origin, that's a problem. So we need to plug in any other value. Plug in any value for x. I'm not sure where my pencil's acting up. Value for x. Okay, so what are we going to plug in for x? We can pick anything. So let's go ahead and just pick, I suppose, let's go ahead and pick 2. So we're going to say let x equals 2. Okay. There's the bell starting school. You just heard it. All right. I was hoping to finish before that bell. Okay, so when we plug in 2 for x, what happens? We get 2 plus, that's what we plugged in, equals 2y equals 0. Okay, we're going to subtract 2. We get 2y equals -2. You get y equals -1. Now we have 2 points. We have 0, 0, of course. Both these were the same thing, so that didn't help us. But now we plugged in 2 for x. We said let x equal 2, and then we got y equals -1. So now we have a second point. 2, 1, 2 in the x direction, and -1 in the y direction. This is our second point. Now we know which way this line is going. Okay, and that's how you do it in standard form. If you get both at the same location, you just need to find any other point by plugging in any value for x. Okay, next time we're going to talk about vertical lines, midpoint formula, blah, blah, blah. You'll see it. And yeah, so this is part 2 of this. This is a long section, but thank you for watching, and I'll see you next time.